In this problem, we are going to explore making families of parallelograms. The goals of the day, GTD, woo woo, are to introduce what we mean when we say families. We'll intro problem 3.2. Then we're going to practice making parallelogram families. Then there'll be some homework. And then of course, as always, we have fun. What you need your textbook. Open that to page 57. Obviously a pen or a pencil, some paper to work on, and of course your iPad, or you wouldn't be watching this. Hit pause, get everything you need, and when you're ready, press play. So you should have your textbook open to page 57. So we learned that with the area of parallelograms, it's quite simply the same as the area of a rectangle, right? Because we talked about parallelograms are really just rectangles that are slanted to the side, that are kind of blowing in the wind. So your area is length times width, but with parallelograms, we change it to base times height, right? So when we talk about families, the question that I want to ask you is, when you have two parallelograms that have the same base and same height, will they have the same area, right? And depending on whether you switch the way that parallelogram looks, is the area still going to be the same if you still have the same constraints of base and height, right? Even if those interchange. So we're going to explore that. So if you look at problem 3.2, it says find the area of each parallelogram twice using the different side as the base each time. So you can see I've done this for you because you would, if we were in school, you would take this and put it onto a centimeter grid and figure out how long it was. But essentially, when you're looking at this, your base is 6 centimeters, right? And your height is 3 centimeters. So we simply go area equals base times height equals 6 times 3 equals 18 centimeters squared. Make sense? But what if we make the base 3 centimeters and the height 6 centimeters? So let's look at F, right? So you've now got your base, which is 3 centimeters. So imagine that you kind of have to tilt your screen to figure it out, right? So you climb up to the top of that parallelogram. You come this way, right? Drop the rock straight down, and that's your height. So your height is now 6 centimeters. But the perimeter, or the area, is the same, right? So area is still 3 times 6 equals 18 centimeters squared. So even though we flipped it, because we kept the numbers the same, although the base was 6 in the first one, the base became 3 in the second one, the height was 3 in the first one, and the height was 6 in the second one. So the numbers just flipped. So as long as you keep the same area, because you're keeping the same numbers for base and height, that makes it a family. But what you have to know is the perimeter can be different, and we'll talk more about that. So let's continue on to problem 3.2. So look at this paper right here, right? So it says draw a segment 6 centimeters long on a separate piece of paper. But let's just look at this one. So we've got it 6 centimeters long. Right here, right? And we're going to use that. Then it says, when you look at B, it says sketch 4 different parallelograms with a height of 4 centimeters. Well, let's do the first one together. So let's just make it simple, right? We count our height. We go 1, 2, 3, 4. So we know it needs to be up there. And if I make a parallelogram, a non-rectangular parallelogram, I just need to move that point over 1. But when it's got to be 6 centimeters long on top too, right? So we go 1, 2, 3, 4, 5, 6. And then I make that connection. And what is the area for a parallelogram that has a base of 6 and a height of 4? What is that area? Do you know it? All right, so let's remember what we talked about. So our constraints, or what we need our parallelogram to look like, is that the base is 6 centimeters, right? So I did the first one, where we've got a base of 1, 2, 3, 4, 5, 6. And our height was what? Our height was 4. And height is 4 centimeters. So we go 1, 2, 3, 4. So I just go up there. 1, 2, 3, 4, 5, 6. So that's the first one, all right? Base equals 6, height equals 4. How can I make a different one? Let's go. Let's do this. Let's start 1, 2, 3, 4, 5, 6. So what I can simply do is I can just go down further. 1, 2, 3, 4, 5, 6. And make the connection. So this looks different, right? But my base is still 6 and my height is still 4. Well, we can keep going this way, right? We could go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So see what's happening to my parallelogram is the area is staying the same, but it's definitely taking a different shape. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So this parallelogram looks much different than the one up top, but it's the same area. So what does that tell you about families? Parallelograms that have the same base and the same height, whether they're flipped on their side or not, are going to have the same area. But the perimeter will be much different because your base here is 6, the length of this is 6, but the length of this side is much different than the length of this side. So although your area is the same, the perimeter is different.